What's up, Kagabats? We have another video today. And this time this video is going to be about something called imaginary numbers. Um, they're not imaginary. They are very much real. Okay? They're as real as any other number, which is why on the title they're all, you can see it right there in parentheses, they're called lateral numbers. But here's an article as why they're called imaginary numbers. Originally coined in the 17th century by René Descartes as a derogatory term. That means when they were first introduced, this dude, René, he thought they were a joke. He's like, you can't do that. That's not real. That's imaginary. You're just making math up. Well, I mean, all math is made up, right? Math is invented and discovered at the same time. So he made it up. When they were introduced, he didn't think that they were worth it. It was like, what are you doing, dude? This is just nonsense math, right? As a derogatory term and regarded as fictitious or useless. But then, as mathematics improved and became more complete, Leonard Euler, real smart dude, they started, gaining acceptance when this guy worked on them, right? So, just letting you guys know, imaginary numbers are real. That's why they're also called lateral numbers. Okay, a lot of people think that we should call them lateral numbers instead. Lateral numbers. Because when you hear imaginary, you're thinking it's not real, but they very much are real. So what are they? Let's take any number we have. For example, I have here 5 to the power of 2. When you square it, you get a positive number, positive 25, right? What if I take negative 5 and square it? Well, then that's negative 5 times negative 5. Because remember, the square means that the numbers be multiplied twice. So negative 5 to the power of 2 is negative 5 times negative 5. And you get 25 again. Oh man. So we're running into a problem we see here that whenever we square a number, whenever we multiply a number by itself, you get a positive number no matter what. And that's a consequence of multiplication, right? Because when you multiply a positive times a positive, you get a positive, right? Positive number times a positive number equals a positive number. Well, what if I do negative? Well, negative times a negative is still a positive. So we're running into an issue here where we can't possibly multiply a number by itself to get a negative number. You can try yourself. Some of you may think, well, what if I just do this? Well, this is not the same as this, because what this means, negative 5 squared, is not the same as the quantity negative 5 squared, because this means this. Negative 1 times 5 squared. See? The square right here is only affecting the 5. It doesn't affect the entire thing like it did up here. Alright? It doesn't affect the entire thing. So, this number right here becomes negative 25. But it's not fulfilling the condition we want it to, where we multiply a number by itself and we get a negative result. So what imaginary numbers do, lateral numbers, they give us another number system, or I should say they expand our number system to help us get a negative number when you square it. Because even if you get to 0 squared, you get 0. It will never be negative, ever, right? Negative 3 squared, positive 9. Negative 4 squared, positive 16. We can't get a negative number. So the guy that introduced negative numbers, he's like, wait a minute, what if there's a number system or a set of numbers that can give us a negative result? So let's use our number we have here. So if I take the square root of both sides, right, you get back 5 is equal to 5, and we're good. So if we take the square root of a number, what if we get a negative result? Like, what happens? right? The square root of 25 is equal to positive 5. Or we're just going to call it 5, right? Is equal to 5. Okay, cool. But what if I take the square root of a negative number? What if I do the square root of negative 16? What happens now? In our number system that we just discussed, there's no way to get a number. In other words, we're asking ourselves, what number to the power of 2 gives us negative 16? It can't be 4, right? And it can't be negative 4. Because if you square 4, you get 16. If you square negative 4, you still get 16. So what number is that? Well, there's a little trick we can do. Instead, we're going to do this. We're going to split the number inside the radical. The square root symbol is called the radical. We're going to do this. Negative 16 is equal to negative 1 times 16. So far, so good? Cool. So that means that I'm going to split the inside up like this. So far, so good. Now, as a property of radicals, we can do the following. Oh, let me leave that up there for you guys, actually. All right, now let's do a little bit of math here. Well, when you have a product inside the radicals, you can actually split them up like this. So that's going to be the square root of negative 1 times the square root of 16. Like this. You can do that. Now we know what the square root of 16 is. What number times itself gives us 16? Well, that's just 4. So here we're left with the square root of negative 1 times 4. And that's the number. Well, you can do that with any negative. Any negative whatsoever, you can do that. Okay? So let's rewrite this. Usually when we have a radical and a number, we want the number on the front. So our new number is going to be 4 times the square root of negative 1. Let's multiply that number by itself. And if we get 16 back, negative 16, then we're good. Right? Because that's the definition we want. So let's do that. I'm going to take the new number we just have right here, and I'm going to multiply it by itself. I'm going to square it. So here I go. 4 times the square root of negative 1. And I'm going to square that right there. I'm going to square that. Okay? Before I move on, let's get one thing going. Anytime you square a number, you get the inside result back. Because the square root and the square, they're like opposites. They're kind of like addition and subtraction. They undo each other. They are inverse operations. All right? So we're going to do that. Let's move it right here. This is what we're working with. So let's use this property. But when we're multiplying, you can actually distribute the exponent into both of them. So here I'm going to get 4 squared times the square root of negative 1 squared. Like that. All right? If you want, you could put parentheses around them. Just like that. I'm just going to do it for the first one, for the square root of negative 1. So here I have, well, 4 to the power of 2 is equal to 16. And by our little definition right here on the right, the square root of negative 1 squared is equal to negative 1. And we get negative 16. Hey, yo, we did it. We have successfully made a number that when we square it, we get a negative number back. And this is how they work. But instead of writing the square root of -1 all the time, we have now we have a new notation for it. Okay? So let me get rid of everything and show you guys a new notation. All right. Let's define the square root of -1 as equal to a variable called I. Okay? So now when we have I and we square it, we get -1. And this right here is what we're going to be using. All right? We're going to be using this new unit as the base of our imaginary number calculations. So with this, we can now find the square root of negative numbers. Let's try to find the square root of -9. Well, first I'm going to split it up as the square root of -1 times, let me put the number first, as 9 times -1, right? And then I'm going to break apart the inside. So the square root of 9 times the square root of -1. So that means the square root of 9 is 3. And what's the square root of -1? We have a new definition for this little guy. Right here. This is simply equal to I. So we can just replace it. So instead of saying square root of -1, I'm just going to say I. And there we have it. The square root of -9 is equal to 3I. And we can test this. All right? Let's test it by multiplying it out. Let's square the number. And if we get -9, we're good. So 3I squared. This equals 3 squared times I squared. When you're multiplying, the exponent does distribute. Only when you're multiplying though. When you're adding, it does not. So now, what's 3 to the power of 2 equal to? That's 9. And what's I squared? Right here in the yellow box, we have it as -1. Which means that we get -9. Voila. We did it. Let's do another example. All right. Let's take the square root of -100. I like to put this little tail right there to tell me that this is where the square root ends. So let's rewrite this. The square root of 100. Sorry, I skipped a step. The square root of 100 times -1, which is equal to the square root of 100 times the square root of -1. The square root of 100 is 10, and the square root of -1 is just I. And there we, sorry, the square root of 100 is 10, and then the square root of -1 is just I. And there we have it. So the square root of -100 is equal to 10I. Just like that. Pretty amazing. Let's do another example. Let's take the square root of -81. Well, here we have of 81 times -1, the square root of 81 times the square root of -1. Well, the square root of 81 is equal to 9, and the square root of -1 is just I. So there we go. So the square root of negative 81 is 9i. And that's really all there is to it. It's pretty cool. So here's a little table. Let's make a little table of square roots. So here we have the number n, right? And here we have n squared. So if I have just I, well, I squared is negative 1. If I have 2i squared is negative 4. 3i, negative 9. 4i, negative 16, and so on, so on, so on. And here's another table, but this time n is a real number. All right? Look how they're related. What if it's just 1? Well, 1 times 1 is just positive 1. Right? What if it's 2? Well, that's 4. All right? Well, if it's 3, that's just 9. And if it's 4, that's just 16. Okay? And that's all really there is to it about these numbers. In fact, these numbers also work. Negative imaginary numbers also give you, let's say I have a negative I squared, right? So let's try that. What happens if I have a negative imaginary number, right? What if I have this? Negative 2i and I square it. Well, let's do the math. So negative 2i is the same thing as saying negative 1 times 2i squared. When you're multiplying, the exponent distributes into everything. So here I have negative 1 squared times 2i squared. Negative 1 squared is just 1, but 2i squared is negative 4. So we still get negative 4. Just like we would if I do 2 squared, you get 4. It doesn't matter if you put a negative in front of it. It won't change the result of imaginary numbers, right? So that means that negative 2i squared, that's the same as 2i squared. You get the same result. Here you get negative 4, and here you get negative 4. Okay? Just like if you square 2. 2 squared is still equal to 4. Look at that. The results are the same. Pretty cool stuff. Alright? So this right here, these units right here are what complete the number system for us. Alright? So now we can take the square root of negative numbers. So the square root of negative 2, well, I don't know. Let's do it. So that's the square root of 2 times the square root of negative 1. Well, the square root of 2 is not an exact number. It's irrational. It's like a repeating decimal. So I'm just going to keep it as a square root of 2, and I'm just going to put I in front of it like that. Just like that. But make sure that the square root is no longer all over it. It's just on top of that 2. It ends right there. Because if you square it, watch this. Negative 2i squared. Let's see what we get. The exponent distributes, so we get negative 2 squared times I squared. The square root of 2 squared is just 2, and I squared is negative 1. We get negative 2 back, which is what we started on the inside. Alright? So now we know how to do the square root of negative numbers. I hope this was clear, and we're going to be working with imaginary numbers as we do more exercises. So if you guys need more practice, or if you guys would want me to solve more problems, just let me know, guys, and I'll be happy to do so. See you later. Peace.